conducting this session today. So we will, you guys can tell me if I'm audible or not. Yeah, you can unmute yourself, or you can put something in chat that if I'm audible or not.
Yes, sir. Audible, sir.
Thank you. Thank you. Okay. So we'll be starting the session in just 5 minutes. We'll just wait for other students to join in, and then we'll start with our session. In the meantime, I would like to, just a minute. I'd like to say a few things. So towards the end of the session, I'll be sharing a feedback form link, which if you guys fill it up, you will where you can choose what sort of career paths are there in the area of your interest. And based on that, you'd also recommend it with the free course that ETG provides. So that way you will have something to look forward to. So stay tuned till the end of the session. And we also have Dr. Ashish Patel, who's Training and Placement Officer of Lakshmi Institute of Technology. And I'm happy to announce our association for this bootcamp. On behalf of ETG, I happily welcome you on board. We appreciate mentors like you who take initiative in guiding students to become industry ready. And we also have students joining from Lakshmi Institute of Technology of 2nd, 3rd, and 4th year of Mechanical and Electrical Department. So for all the students, I think Dr. Ashish, you're here. So would you like to say a few words?
Hello.
Hello. Yeah.
Welcome. Hello.
Hello. Yeah.
You're audible?
Yes.
Yes. Thank you very much to give me the opportunity to speak something about something about this seminar. And welcome my all students who is joined from Lakshmi Institute of Technology. And this is a good. I learned about this strategy and about the topic as well. And this is a good topic, and it is useful for the final year, pre-final year students. And even in the it is very useful for the student in the future scope about the marine technology and robotics technology. So welcome all. Thank you.
Thank you very much for those lovely words, Dr. Ashish. It was a pleasure to have you here. It's great. So I'll just let's just wait for a couple of more minutes and we'll start. So as you all must have read while you're registering for the webinar, basically it's about submarines and how this technology is developed, where it is going, how it is utilized. So basic concepts behind it and its operation, its limitation to a certain extent, and how we can work on these limitations. So these things we'll talk about in bit much detail. And yeah, so let me share my screen. Yeah. So as people will tune in, without wasting any time, we can start with our session. We will talk about submarines, the mechanical monsters of the deep. Due to the sheer amount of size, like they carry the amount of components that they carry, That's a really interesting and like a very advanced equipment of technology, and it's a very much interesting topic to talk about. So first we'll just see what submarines are exactly. Then we'll talk about how it submerges and resurfaces, which concept it's based upon, and how basically the dynamic works. Then we talk about how does it see underwater. So what is navigation system looks like and works with. And then we'll talk about its propulsion system. So what sort of dynamic is there in order to keep the submarine going underwater for a period of months. So those kind of details we'll dive into, and then we'll talk about a general idea of what is how life is on a submarine. So with our topic starting off, here is a basic model of a submarine. Like this is how a modern submarine looks like. It's basically designed as cigar shaped. It's also called as teardrop hull. It is designed in this peculiar way, it's a specific way, in order to withstand the incredible amount of pressures when it goes deep dive. So this is the most optimum shape in order to withstand the huge amount of hydraulic pressure that it is under. So that's why we usually, while moving under that level of pressure, and that generates a big level of hydrodynamic drag, and it kind of creates like restrictions to the motion, and that's why we need a more amount of power in it. So in order to make it more hydrodynamic, we use this teardrop hull as a shape. Also, it has a raised tower, as you can see over here. Basically, just a minute. This part. So this part will be all the electronic components that are there: the communications, the radar, the periscope. Also, the advanced mast system, which is used to navigate, or all the navigation systems and radio electronics will be mounted over here in order for better communication, better range. So yeah, so that's the general idea about it. Now, can anybody tell me this concept of buoyancy, what it stands for? Hello? Yeah, you guys can unmute yourself, or even drop something in chat. Like what do you guys mean by buoyancy force or buoyancy?
Anything immersed in a fluid, the upward force exerted by the fluid due to the weight displaced by that object.
Okay. That's exactly correct, Abdullah. Now I want to understand from your point of view, like how is buoyant force relevant in this context? In the context of submarines, how buoyant force is relevant? Can you guys tell me? So I'll give you a little hint. It has something to do with diving. Okay. So basically, what happens is you have your as Abdullah said correctly, basically if this is your like a jar of water, and if you drop a stone inside it, so the amount of water displaced by this dropping of this stone inside the water will have a weight which is equivalent to the buoyant force or upward force the water is going to exert on this submerged stone. So that is what a buoyant force is. Now, let's see how this concept is utilized in these submarines, right? Basically, if you just a minute. So let's have this submarine. For simplicity, I'll just draw it as a bun, okay? And let's have this is your water level, and it is submerged, okay? Now, what basically happens is in your submarine, there is a empty shell. Just a minute. So in this empty shell, basically, it's not a complete empty shell. It's a segment of a submarine, which is an empty shell, in which there are walls installed. So at the bottom side and at the top side, there will be walls will be installed, something like this. So when you want to go into deep dive into submarines, what happens is basically, first off, you will have this vacuum inside this that will regulate the weight of the submarine such that it will float on the surface. So at the start, basically what happens is this is your submarine at the null position, at basically where you don't have any water inside this empty shell. These empty shells are what called as ballast tanks. In those ballast tanks, they are basically used to regulate the diving and resurfacing of the submarine. And how it is regulated is basically by inserting more amount of water. So can anybody tell me, if I fill this vacancy with water, what will happen to my submarine?
Hello.
Yeah.
Actually, the submarine will go deep in the water due to the actual weight of the submarine is increased, and the submarine goes into the deep water.
Okay. Okay. Cool. Good. Now, what if I want to resurface? In that case, what should I do?
To reach the surface, we need to empty these tanks and create the vacuum inside these tanks, so we can get into the surface. Like if we put a empty water bottle in the any lake or that, we see the water is floating on the
आवाज नहीं आ
surface.
रहा है सर.
Yeah. Go ahead.
And if we put water bottle with the full fill, so the water bottle is goes into the deep water, like that, same as in
सर
submarine.
आपने खुद को म्यूट कर लिया है.
Hello. Okay, never mind. So, as somebody was saying that exactly the same thing. What we do is we first fill the whole tank with water in order to deep dive. Then, if you want to resurface it, we basically empty the tank out. Now, let's understand this concept in a much better way. Okay. So here, this is the cross section of the submarine. Okay, and here, as you can see, these are basically the walls through which you can empty out the air, you can fill in the water, and then balance it out same way. So these are the four walls that are being basically used. And over the span of the submarine, basically they are installed in such a way. So if you take this as a submarine, you will have your rear ballast tank and your front ballast tank. So this is the cross section that you are seeing over here. If you look from, just a minute, if you look from this side, you will see that this is the section that we are actually looking at this stage. So there is one more idea behind this submerging resurfacing ideas. Basically what happens is, if you regulate the quantity of water and air in a positive, in a better proportion, in that case what happens is basically your submarine will be stable at a particular stage. So let me show you how what do I mean by that. Now let's consider this is my water level, and this is my submarine. Okay, so here is my front ballast tank, here is my rear ballast tank, and the start of the submarine, what I have to do in order to dive into the into a particular depth, I will I will not fill up the rear ballast tank, but I will fill up the front ballast tank. In that case, what happens is my submarine slowly tilts down, something like this. Okay, and this will give the submarine a better push in order to get into the deep zone faster. Essentially, it is swimming down. Essentially, it is swimming down, and basically, uh, excuse me, does somebody have any doubt? Hello. If you have any doubt, you can unmute yourself and tell me. Otherwise, please don't create any disturbances while I'm explaining. Okay.
Continue.
Okay. So basically, what happens is you will have your ballast tank. Once you fill the front ballast tank to a certain extent, you will tilt your submarine and it will like descend down the into the deep waters. At a particular stage, now, if you want to, let's suppose at this particular level, you want to make the submarine stable, basically attaining its horizontal position. That case, what you do is when you are trying to approach this stage, you start filling up the rear ballast tank, and that way, if you keep the, let's suppose this is your ballast tank, and this is your water, this is your air. So if you keep this proportion in with a certain amount of like 50-50 or something, that case basically your submarine will be stable underwater. Now this is the diving concept. Same thing we do for resurfacing. In resurfacing, can you tell me what would be the order of business, like how we will go ahead with the resurfacing? First of all, I want to ask, like, is this concept clear to you?
Sir.
Yeah. So this concept is clear to you, right? Hello?
Yes, sir.
Yeah, good. So now let me redraw it. And at this stage, let's just start at the bottom. Okay, now my submarine is at this level. Okay, now I want to resurface it from this particular point. Let's suppose this is my rear ballast tank, this is my front ballast tank. This is rear, this is front. Okay, so first off, my first question is, at this stage, what is the status of this ballast tank? Can you guys tell me?
Both are filled with the water.
Both are filled with the water. So are they
Yes.
completely filled with the water?
No, not completely, but half.
Okay.
As the submarine is not in deep water, it's in between.
Okay, correct. Now, if I want to resurface this submarine and I want to bring it over here, what is the process that I need to follow?
First, we need to empty the rear tank to reach the quickly on the surface.
Okay. So if I empty out my rear tank at this stage, let's suppose, I will have this angle, right? I will have this angle because I'm emptying my, not here, just a minute. Here itself, I will have this angle. in which my rear tank is currently emptied, and my okay, just a minute. So when you say you want to empty your rear tank, can you tell me why do you first empty your rear tank?
To get the angle.
To bag
In
in.
in order to lift that submarine to the above level.
Okay, okay. So I'll tell you what happens at this stage if you empty out your rear tank. Basically, you are releasing weight from this side of the submarine. In that case, what happens is, again, you will have this angle. So basically, your front tank will go downside, your rear tank will go upside. In that case, your front end of the submarine will point towards the bottom side and rear end will point towards the upside. So in this situation, is this correct first of all?
No.
No, no.
No, sir. Reverse process. Like it should be in the reverse direction.
No. You need to first clear the first tank to get the angle, and then just slowly empty the rear tank after getting the first.
Correct, correct. So basically, this is what these guys are talking about. First, we'll empty out this one. Then we will have this angle. Then slowly we will empty out the rear one. Then slowly go upstairs, and here we will have a submarine over here. So this is the basic mechanism of diving and resurfacing, and how this dynamic works. Now, another question arises. What about the air? How are we maintaining the air? How are we refilling and emptying out? Can anybody tell me? So because you are underwater at this stage, you're underwater, right? So you don't have the means, if you take this concept as just a concept, you don't have the means to pump up air or basically to empty this thing out, because at this stage you will have immense amount
So
of
we
hydraulic pressure.
need to then separate the water particles, like H2O, separate the water and the air oxygen.
Okay, okay, that's interesting. Okay, so focus on the question. Okay, what my question is, I have this stage. Basically, at this stage, if I'm filling up the air, if filling my ballast tanks with the air, it is understandable because I'm floating, because there is air available which I can access and I can fill it up. At this stage, if I release the water, I need something in order to push that water out. So think on it a bit and tell me what could be the thing that I am using in order to push the water back in order, because at this stage we will have immense amount of hydrostatic pressure, and here, as you said, this tank, if you want to empty it out, we need to balance the pressure out. So how are we going to do that? Does anybody have any ideas?
We can do it by increasing the pressure inside the tank by using some pump or equipment like that.
Compressor.
Correct. So what happens is, basically, you see this this big chunk of what you can call it tower at the top. Here there are two separate oxygen not oxygen but air tanks. Okay. Now these air tanks are very highly pressurized, and using this pressurized tanks, we are basically forcing the water out, again retracting the air, creating a vacuum inside, and we're basically coming on board. So that way, basically we are maintaining the integrity of the ship. We are also maintaining the diving and resurfacing phenomena, and that way we are trying to accomplish this particular dynamic. Okay, so this is about the basics of like how we are submerged into under the water and how we are resurfacing. What about the next? So
Excuse me.
yeah,
Which fluid is used in those tanks present in the tower?
which fluid is used? It's air only. It's normal air. It's basically those small tanks are specifically designed in order to insert air in this. So basically, you see these walls, right? So these walls are incorporating air from external means. But if you are inside over here, then in that case, you need to basically, if you are at this stage, completely submerged, right? Completely filled with water, you need to push this water out. So here there are tanks installed, and through which basically all these four walls are opened up, and from all these four walls, the water gets pushed back. Then there is a mechanism for it, and like seals and everything. So once the water is pushed back, basically you will seal it up, and accordingly you will basically be able to afloat in and basically resurface. So that's the dynamic here. I hope that answers your question.
I think.
Yeah. So, as I said, like this was okay. Before I move on to the next thing, if anybody has any doubt with this particular concept, they can talk to me. They can tell me.
So actually, like you're asking for the like air, like how we'll get the air inside when it is being submerged. So like I did not get like completely like the answer what you said like for that.
Okay. So what happens is, before submerging, our submarine is floating on the surface, on the seawater, right? Yeah, in this tower, there are tanks installed. Those are pressurized air tanks. In those pressurized air tanks, basically, once we are before diving into the water, we will fill those tanks up. We'll make sure that they are at the optimum pressure, which is able to withstand and be able to force the water out of this ballast tanks. That way, we will be prepared before diving into the water, and that's how basically when we are submerged, we will make use of these tanks in order to resurface. So try to think of this size wise. Okay, so it's a very big ship. It's almost 2.5 to 3 times of that of an airplane, Boeing 747 airplane. You can Google that. So that way you will be able to grasp the size of this submarine, the size of the actual monster it is. So in that, basically there is what you can call it, artificial artificial pressure is created in order to sustain life and in order to have the crewmates working in that environment. So all these things are used and made sure that things are properly ordered. So that's the core idea.
Okay, like you mean to say that like they have been filled before itself in the pressurized tanks.
Exactly.
Okay, sir. Yes, thank you.
Yeah. Anybody has any other question?
No, sir, continue.
Okay, cool. Okay. So,
sir, one question, sir.
Sure, go ahead.
Sir, what can a submarine do?
Does anybody want to answer it?
Yes, sir.
No, I'm asking the rest of the audiences.
To defeat the other submarines which have been underwater and other like ships and other things like underwater. So it helps to defeat.
Sir. Okay, cool. So it's one of the features of submarines. Like it's basically used to stealthily go into enemy territories, spy on them, collect information, what sort of dynamic they have going on under their waters, and collect like feed those information back to the base, and accordingly have an edge over your enemies. That's one of the ideas. Second thing is, if you are ever going to like war zones or something, in that case you will have waterboard fights, and in that submarines are basically used to launch the missiles. So though that is one of the other ways for that is one of the key aspect of submarines basically. So it's what it's used for. Now let's continue. Basically, here you will see the complete submarine and its control surfaces and wings. So there is this forward trim tank, there is this rear trim tank, and there are these main ballast tanks. Your forward and rear trim tank. So this is basically deep diving into the concepts. So previously we only seen like there is a front and rear task in order for change of angle and all these things. Still, even if you change the angle and basically these rear and front ballast tanks are basically used to change the angle. But your main ballast tanks are situated over here. Those, once you empty out, they will reduce the weight of the submarine and they will try to take it upwards. So this is a one step further into the concept, into the detail of the concept. Basically, this is how it is being done, and it is controlled with a control system. It's extremely precise, and accordingly, this resurfacing and diving is getting control. Now, let's see. Yes, Viresh, go ahead.
Sir, this ballast tanks will be present like externally or internally it will be fitted, sir?
It will be internal. It will be all internal.
Okay, thanks, sir.
So, how does now the another question is, how does it see underwater, right? Because you are at a depth where light cannot pass, or light basically won't pass due to the water heights. And basically, how are you going to navigate through the waters? How are you not going to hit a boulder or something while you are underwater? So there is sonar concept, sonar technology. Basically, you send out radio frequencies and you emit radio frequencies, and you will also have a receiver which will catch the feedback of those emitted radio frequencies. And accordingly, it will tell you with the frequency of the radio waves that you have emitted, the difference between that, you will be able to understand that at this particular distance, I have an object which I need to avoid, which basically the sub needs to avoid. So how this works is, so first you will send a strong radio wave signal. You will note down its frequency, let's suppose X hertz. Then you will get some kind of feedback from basically the radio frequency will hit this boulder and come back as a feedback frequency. And the magnitude of this wave would again be reduced due to some losses that it will face while moving underwater, while moving through this fluid medium, also by interacting with this boulder. And once you actually calculate the loss of the radio wave, let's suppose you will get Y hertz is your radio frequency, and X minus Y will give you the amount of frequency you lost, and accordingly you can calculate the amount of distance which you will have between the submarine and the boulder. So this we are talking about with just one single rock, but in actual thing, what happens is there are multiple such feedback waves are collected from all sorts of things. So let's suppose there will be fishes, there will be some other things involved in underwater. So some of these things, basically you will get a lot of noise. In noise in the sense that you will get a lot of unnecessary feedback transmitting wave or transmitting signal. And that might interfere with your original signal which you want to focus upon. So let's suppose we have this big boulder, we have this small boulder, and we have some animal or something moving here. So all of these things will emit some feedback frequency to the emitted frequency that we will send back from our submarine. Now, in order to counteract this, basically what submarine what the crew does is, or basically what the operations does is, they will emit some unnecessary feedback. So let's suppose this fish is not very significant. So the feedback coming from this fish is not very significant. So there will be a frequency, theoretical or even operational tested frequency, below which all the feedback signals are considered noise, basically, and they are filtered out. And then you will only get the actual frequency, actually emitted frequency that you would want in order to understand, like, this is a big boulder that I need to avoid at this particular stage. It is at this particular distance. So this is how this dynamic works with the radio frequencies and sonar. Now, is everybody clear with this concept?
Yes, sir.
Anybody has any questions? Anybody has any doubt? You want me to re-explain this?
So the last part, like you told about the frequency, like how it can detect about some fishes and like the stones and any disturbance like that.
So how do we detect it?
Yeah. How can we detect like that thing?
Okay. How can we detect, like, based on how can we detect the size of it? How can we understand? So it essentially depends on the feedback that you're getting. So if you have a small object, the interference, or basically, okay, take it this way. I'll go to an empty slide in order to explain this. Let's suppose this is a big boulder, this is a small boulder. I'll have my So basically, I will have this kind of emitting frequencies coming from the submarine, and same thing over here. But the reflective signal sent back from these two boulders will be different. Due to its size difference, you will receive smaller segment of refractory waves as compared to this. Again, this comes down to frequency. Frequency is a measure of the amount of what you can call it, amount of resistance you get or feedback you get once you emit something, once you emit a wave. So that will again reduce your wavelength. That will reduce your magnitude. And it's a very like a tricky thing. If you have a better understanding of how radio waves or radio frequency works, in that case you will be better able to understand it. But the basic gist of it is simple, that due to the size of it, the emitted feedback also differs. So smaller the element, you will receive very minor feedback from it, and that's how you can detect, like, this is a very small object that I have in front of me. This is a very big object that I have in front of me. So that's how basically it is detected. And this is not done for shorter distances, because at shorter distance, you mean like within 1 or 2 meters of the submarines, you will have like halogen lights installed. So essentially, you will be able to see the immediate water body, or immediate something that is really very close to the submarine body. But this is used for once you have something, let's suppose 100 meters away, 200 meters away. In that case, you can't have focus light. You basically, light won't be able to pass at that distances. Beyond that particular distance, you will have these radio frequencies to judge that whether I have a boulder in front of me or it's just a small fish or something. So this is the idea. I hope that answers.
Sir, like another question, if you don't mind.
Yeah.
Sir, like you said me that the based on the size of the object and the distance, like they can detect that, like the radio frequencies will be back, and then they can detect that how the any object is present or like. So if there is like if there is a stone, big stone or rock like that, and there is a whale like fish. So how can they detect between difference between them? Like that is a rock and this is a fish. Like there will be in the difference, right?
Yes.
So it will be like the fishes will be moving and in the moving from place to place. And when they are the race will be detected, so it will be detected like the fish is present there. So like they think that there it is a rock. So how can they differentiate between them and they can move with that?
Okay. So basically, you actually answered this question yourself. You will have a stationary rock that will produce a significant amount of signal, and it will have a significant frequency, and that frequency will be stable throughout time. So even after I see the frequency after 5 seconds, after 10 seconds, it will give me the same feedback because it's a stationary rock. If it were to, if it was a moving object, in that case, based on the movement, there is slight interference created in the feedback. So essentially, that way you can detect that something is moving. Okay, that is one way that I know of in order to understand and detect, like if the object is moving or the object is stationary. In order to detect if it's a life form or if it's a like a normal object. I'm not too sure about how it is done, but yeah. So this much I can tell you.
Okay, thanks, sir.
Okay. Cool.
Hello, sir.
Yes, Pawan Kumar.
What is the purpose of the propeller of the submerge?
Yeah, I'll come back to that. Just a minute. Other than that, are there any questions about this radio frequency thing? Or how can a ship see submarine seas underwater?
Hello, sir.
Yeah.
Sir, how will it differentiate between a whale and another submarine? Like both will be moving. So how will it differentiate?
So apart from the radio frequency, there will be electronic signal. So with the recent advancements that are there, there is a certain way to detect that if it's a submarine or if it's basically if it's a mechanical or electronic component or if it's a wave. So again, I'm not sure about this, how it is done exactly, but in future sessions, I might dig deep into it and I might try to cover that aspect as well.
Okay, sir.
Okay. So now that we have seen how does it sees underwater, let's see how does it sees what is happening in the outside world. So basically, you will have an equipment called Periscope. So what happens in this Periscope is there are a bunch of mirrors installed at a 45 degrees angle. So let's suppose this is your pie, okay? And your light rays are coming basically from this direction. Let me just complete the drawing, just a minute. You're at here. You're seeing from here. Okay, so there are mirrors installed at 45 degrees angle, which basically translate the light from this point to this point. And it will basically capture whatever this lens sees in terms of light fragments, and that is transmitted to this stage. That's how you can see above water what is going above water. But in order to see this, there is a limitation. Basically, if you are suppose just a minute. Okay, over here. Yeah. If you are over here, like deep under the water, in that case, you will have a limitation of extending this periscope rod. So you can extend this periscope rod to a certain extent. It's not always that you will be able to extend it to the top, no matter what depth you are at. So there is one limitation for this. That is, you have to come above at a certain height in order to actually access this periscope. So this is another way that is used for hundreds of years. This is another way because for detecting if there are any submarines there in the waters or something like that, or there is any ship, enemy ships or anything like that. Because as the submarine that we have has this particular limitation, the enemy submarine would also have this same or similar kind of limitation at that era. I'm talking about like around 40, 50 years back, even 20, 30 years back. So this particular limitation comes forward with, and in order to eliminate this limitation, there is a device called snorkel mast, and that is basically installed above the tower, basically here, in this facility itself, so that you don't have to extend it too far. Because see, when you are at the periscope here, there is no personnel on board. This is just an electronic equipment side of the submarine. Here, there are 3 different kinds of decks in which, in the case of periscope, you will have to install your control room over here in a very cramped space, because usually the upper deck and the lower deck is usually cramped due to the inconsistency of the shape and constraints of space to this. So in order to install the periscope, you had to have this. You have to install your control room over here, because you need to have a crew personnel at the periscope at all times, who will be monitoring the activity, or who will be basically at that station, in order to monitor that activity. So with the snorkel mast, what they did is they installed an automated device. Basically, it's another kind of a prism things only, but it translates the information using a computer screen. Basically, you will have a sender device or sender server over here, and you will have a receiver server and in the control room. And that control room, basically, you will get the feedback from this snorkel mast. What it is basically seeing above water, you will be able to see that in a picturized format over a computer screen while comfortably sitting in the control room. Now, why this concept is important? Why this is important? Basically, we are eliminating this constraint of having to install the control room at the top deck, and we can actually install the control room at the bottom, at the middle deck, which is basically allowing us to have more space in terms of execution. So I know this is going a little bit out of context, and I'll talk about this at a better stage. But just keep up with me, okay? Just bear with me. So the basic concept with this periscope is we want to see what is going on above waters, and in order to predict, in order to understand the outside dynamics, we can use this, because underwater you might not even understand that there is a storm going above the seawater level, and in that case you need to have kind of a monitoring system, kind of a feedback system, in order to tell you like what is going on outside and what sort of things we should do. So here you will be able to understand the significance of it. Okay, what I was talking about the control compartment, and I'll again talk about the propulsion system and all these things, but let me just cover that particular part. So what happens is, here you will have different kinds of systems that you might need to install. So something like this, like your exhaust system will be there. There will be heavy electronic components will be there, And that, due to this particular system installed over here, you will have lesser amount of space in order to again install a control system or control compartment. Now, with the case of Periscope, we had to install it near this part. Basically, this is your upper deck, this is your middle deck, and this is your bottom deck. So, due to this limitation, the size of the control room became very cramped, and it's very uncomfortable for the crewmates because at times crewmates stay underwater around 70, 80, even 90 days. So for them to be able to sustain in a cramped space, in a very moment restricted space, it is very difficult for them, as if you go ahead with the idea of having to survive in this particular scenario or live underwater for a couple of months. So that case, it becomes very uncomfortable. It kind of takes some toll on the performance as well as a crewmate. So basically, in order to eliminate that kind of dynamic, we'll have the snorkel mast. Basically, that is the connecting system, and in here you will have your control system basically installed at the middle deck with a better space. So if you assume the control compartment shape at the upper deck to be this, in the middle deck you will get at least this much space in order to understand this. So that's the only context that I was speaking with in the regards to the installation of snorkel mast. Also, it gives the better visibility. It has better equipment, but again, it kind of eliminates the requirement of periscope, or basically physical attachment with the control compartment and the observer with the control compartment. Now,
excuse me, sir.
Yes.
So what about the exhaust gases that are being emitted by the diesel generators?
Yes, I'm going into that. Just a moment. Okay. So we have seen about the control compartment. We have seen all these rest of the things, how it sees and all these things. Let's see how it moves above water, underwater. Now, there are two kinds of propulsion systems. One is this diesel electric propulsion system. Second is a nuclear powered propulsion system. With your diesel generated propulsion system, as you rightly said, that there is limitation. We can have diesel generators working when you are above water, because you need to have an exhaust system. You need to exhaust the flue gases in order for this system or the combustion system to work if you are using diesel. So one of the key concepts is when you are above sea water level. So this is a very, you can call it an outdated system. Not outdated, but most countries are not able to afford the nuclear powered ones. So most countries are still using diesel generated based air propulsion system. But yeah, so to tell you about this system, basically you have to stay above water. So basically, when you are at this level, you will start the generator. As you can see over here, there are batteries. And your lower deck is basically just batteries. So with this propulsion system, the diesel generators will charge up the batteries. Then the diesel generator is cut off. Okay, so all the exhaust system and all these things are sealed. Basically, this is all basically sealed. When you go underwater, you will basically use this auxiliary power supply, which will power your propulsion system, which will power your main engine, and you will be able to survive underwater. But there is a very key limitation with this kind of engagement. One is once the batteries run out, you have to again resurface, recharge, and go back down. So usual time frame is about 1 to 2 days, maximum 2 days. You can sustain or stay underwater with this kind of system. But in order to stay for a month long, 70, 80 days, maybe 90 days, you can't use these diesel generators, because there is again risk of exposing yourself to the enemies by surfacing in the enemy territories, enemy water territories, right? So there is a different system, which is a nuclear powered system. So it uses uranium as its fuel and nuclear fission as the generator. So what it does is basically you will have your uranium rods, okay? And okay, let me draw it on a empty sheet once again, because okay. So what happens is, let's suppose this is your uranium generator, not generator, but basically iron tubes that are holding uranium inside. Now you will have a steam turbine or steam engine installed somewhere around here. So what happens is, basically you will have a neutron inserted or basically bombarded upon this uranium rods. The uranium rods will split the nucleus for the uranium and again create more nuclei. All these two more neutrons. Those neutrons will again bombard with the existing uranium, and again, so basically something like this. So this is your uranium nucleus. This is your neuron or neutron. Then once it comes into contact with uranium, basically it is a radioactive material, and this is how nuclear fission happens, by the way. So this nucleus will split into multiple nuclei. Then again, during the splitting process, this uranium, the original molecule, will release the neutrons. It will release some neutrons. Again, those neutrons will come into contact with these things, and the process will continue. So this process generates incredible amount of heat, and you will have, basically what you will do is you'll pass on water. It's a simple concept as heat exchangers, simply. So you'll pass on water through these uranium rods, through this arrangement, basically outside of this arrangement, outside of these rods, from here, something like that. And then this water gets heated. It again passed down through, you can call it as in this context, you can't call it as a radiator, but it works in similar fashion. Basically, you will have another stream of water, or basically a number of tubes installed as a passageways for this water to come and transfer the heat to the existing sustained water. So basically, you are using the heated water or heated steam in this case to generate a boiling point water. Now here, again, remember, this water that we are passing through is high pressurized water. Again, what water we will have, a separate amount of water we will have in a tank, which will be again very much having a high pressure. So you are boiling that water, its temperature is rising due to higher pressure. It's exponentially rising, the temperature is exponentially rising due to this heat exchange, and this will come to a boiling point. Once the steam is basically generated, it will be generated at a higher pressure, higher temperature steam. That steam is used to power a steam turbine, or basically steam engine, in order to generate electricity. And this electricity then is basically used to govern or control the all inner workings of the submarine and its propulsion system. All these things will be governed by this particular thing. Now there will be multiple units. So to give you a general idea, if this is my one unit for the uranium rods, this will be my second unit, and there will be linkages between these two units with a steam turbine. Let's suppose these are my two steam turbines, and these are basically connected, interlinked. So that's how we are, and there is again condensation system which condensates the water and again resupplies it in this particular box, you can call it. So that way you are kind of maintaining the using the nuclear reactor, okay, using the nuclear reactor system you will be basically be able to power the whole submarine. I mean, here in this case, what happens is we are generating electricity even with we are underwater without having the need to um, basically pump up air externally. Still, uh, you will need oxygen to survive underwater. So basically, what we have is a oxygen generators. What happens in this oxygen generators is you will have, let's consider this is a dabba, and in here uh, you will have electrodes installed, and there will be potassium, I think hydroxide or something, which is used as a supplementary kind of solvent or a medium. And this again, it will be filled with water, seawater basically, which is desalinated. Basically, all the minerals and all these things were removed. So salty water is turned into a normal water, and you are oxidizing that water. You are basically creating an electrolysis process over here to release hydrogen and oxygen separately. So here, I think I've drawn it wrong. This is a connection between these two tanks. And the separation is basically your negatively charged and positively charged electrodes will be there. Negatively charged electrode will leave out hydrogen, positively charged electrode will leave out oxygen. That's how you generate oxygen. This water we are using is a seawater, so you can always pump it from the external sea, and pump it in and desalinate it and use it. Basically, desalinated water is used for drinking, used for cooking and all these things, and also it is used for this particular phenomenon, using electrolysis process, creating separating hydrogen and oxygen, and basically providing this oxygen to the crewmates. That's how you are able to sustain like 1, 2, or maybe 3 months underwater without having to even resurface. There is one constraint though. You will need to pack up food supplies, which will last for that amount of time in order for you to operate. So the maximum, I think, the maximum range a submarine could have is a Russian submarine. It's called Typhoon. So it can stay underwater up to 77 days, at times 90 days. So 90 days is the maximum any submarine can stay underwater with this kind of equipped capabilities. So basically, there are very few nations would have a nuclear-powered submarine, including us, including India. India also has a.
Excuse me, one question here.
Sure.
In 90 days, what is the distance it travels?
90 days, what is the distance it travels?
Yeah.
Necessarily.
Because finally, distance is more important.
So,
what is the speed of the submarine?
What is the speed submarine has?
Yes, maximum speed.
Maximum speed. I do know about the torpedoes. I'm not sure about its maximum speed, at what speed it moves.
It may not be more than like our normal.
Yes.
This.
Your vehicles, basically.
Vehicles.
Yeah.
Normal sea vehicles.
Yes. So it's essentially not more than it. Actually, quite frankly, I think it is less than that, because there is hydrodynamic drag involved. There is
very much hydrodynamic. It is fully immersed in water.
Yeah.
Do you think that okay, that has to be studied separately? Yes. Okay, thank you. Please continue. Please.
Yeah. That has to be studied separately. I would actually deep dive into the numerics. I haven't done that, but because our focus is to just explain the concept, how it works, then go into the nitty-gritties of it.
Now in India, how many till now they have produced in Visakhapatnam?
Not sure about that actually. How many we have produced yet, but we do have some, I think some borrowed ones from Russia itself. So one of the early versions of Typhoon we have, I think, and it is kind of like.
I think I read this in somewhere. India first launched the submarine from Visakhapatnam port from Andhra Pradesh.
Yeah. But it's not the world's first submarine.
Okay.
World's first submarine is launched by Russians. I think
Okay, very
it was
good.
during the time of World War II. So I think at that time submarines were in most popular and like core development stage. That time they were launched.
Okay, please continue.
Yeah. So all in all, this is how submarine propulsion works. Simply, you will have either diesel electric mixed kind of a propulsion system, which you need to use a generator to power up the batteries, and again use those batteries, the storage batteries basically, to power up the main engine and the rest of the submarine. Or you will have a nuclear reactor based submarine, which kind of uses nuclear fission concept, generates heat. That heat is transferred through water to generate steam, and the steam is basically used for generating electricity by using a turbine. So that's the general idea. Now, in conclusion, basically we have seen what a submarine is, how does it submerges, how it resurfaces, how does it see underwater and also over water, what are its propulsion system and how it works. So if anybody has any questions with this session, they can surely ask me. I think somebody has raised their hand.
Good overview, Heamnt. Thank you very much.
Thank you, Janna. Thank you very much. Yeah. So, hi, Raj. You can unmute yourself. Okay, never mind. Viresh, you can continue.
Sir, what is the minimum time duration required for the submarine to immerse in the water and again resurface to outside?
It depends, no, which level you are going at actually. It actually depends on that. But it also depends on how fast you are able to fill the tank up and control it. So there are a lot of factors involved in this. Basically, you need to control the pressure of the tanks. You need to also control the walls precisely, making sure that the water is gushing in inside the vacuum that we had, and at what speed the water is gushing in, which also to be understood in order to prevent it causing any damages or impacts to the submarine. Then again, it depends at what speed you want to go into, and accordingly, basically, there is a regulated manner, regulated system, which kind of controls this dynamic, the ballast tank dynamics. So I'm not sure to what amount of time it will take to deep dive, but surely it can. Once you start filling up the tanks with the water, it slowly starts like almost immediately it will start sinking down. So it's not like.
Normally, what depth these submarines will be traveling from the surface of the water?
It kind of depends. So normally it will be around in terms of 1,000-1,200 feet maybe. So that would be considered normal, but in circumstances it is very circumstantial. Basically, what happens is you need to be aware of what kind of technology the enemies have built, and essentially it depends on the advancements of the sonar detection level. So
maybe it also depends on application. If it is a defense, somebody should not notice.
So if it's a recon, if it's going for a recon, it has to go well below like 5,000 feet or something. Then if it's going for a kind of an attack or something, in that case it can have it around. If it's not a stealthier attack, then in that case it can again work with around 1,000-1,200 feet. So it actually depends on what usually attack patterns are and how the severity of the mission is. So yeah, there are also underwater exploration subs, which are completely unrelated to this kind of thing. And they actually go deep dive to 15, 20,000 feet, well below underwater. They actually deep dive at that level. So that is also one of the interesting ways because their focus is only to explore the underwater life. So yeah.
Thank you, Samad. Thank you.
Yeah, great.
Sir, one question, sir.
Sure.
Sir, why does not the submarine sink even thought it's wet, sir?
Can you please ask that question again? Hello. Can you please ask the question again?
Yes, sir.
Please ask the question again. I didn't catch.
Yes, sir. Yes, sir. Why does not the sir submarine sink even thoughts it's wet, sir?
Even though it's wet, you mean wet?
Yes, sir.
As in opposite of dry. Right. So consider this phenomenon. I don't think you completely understood what kind of dynamic I was talking about. You will have, okay, this analogy might sit well with you. Let me reshare my screen. Just have a 2-minute explanation. Okay. So let's have an example of a little experiment. Now I have, let's consider this is a empty bottle. Okay. And this is a glass, not flask or something. And this is an empty bottle. Okay, it's only air inside. Now, if I place it over water, what will happen? Can you tell me? It will float, right? So, in the case of submarines, if you want to float, this concept is your ballast tank. This concept is this region, the outer, like, what you can call it, the gap between the outer shell and the inner shell. Okay. Now consider this is empty. So once it's empty, even though with the weight of the submarine, this is very much calibrated. The size of the ballast tanks, the weight of the submarine, how much weight it will have in order to float over the sea. So this is all very calibrated, and accordingly, you will be able to float over water. Now, once you push down, once you fill this up with, let's suppose, half the water, okay, it will sink up, it will sink down in equal proportions of the weight amount of water that you have added. Basically, you have added some amount of water that you have added to the weight of this bottle, so it will sink up to a certain extent. Let's suppose it comes down here with this. So this is the idea. So basically, it doesn't matter if your submarine is wet or it is dry. It will add a few pounds, maybe few amount of weight, but it is still within their calculations itself. So basically, to answer your question, doesn't affect. It's submerging and resurfacing phenomena. So yeah, that brings me to the end of our session. Actually, our session got extended a little. So time to give you the feedback form. Okay. So a couple of things you need to understand with this form. I have floated the form in the chat. So once you fill up this feedback form, you will be able to avail a one-on-one free mentor session from our end. Our experts will guide you through which kind of programs or which kind of, basically, we Elite Techno Groups are providing different kinds of industrial grade courses in order to give you complete insight, complete picture, because what we have seen is just a surface level knowledge, it's just a concept level knowledge. But you will understand a bit more in depth about different concepts. Like, there are things that goes into play. So while you're talking about any kind of a product, any kind of a component, there will be design requirement, there will be analysis requirement, there will be understanding the extent of the design, and all these things will be there. So basically, you need to understand the extent of the virtual simulatory environment and how these things work. So you need to understand which different domains are there which focus on, like, for simple.
Even my suggestion is probably we may have to work for, or your workshop should be more for the learners on environment, climate change, electric vehicles, green energy thing. I think 2 days back our Prime Minister also signed agreement with German government with something like 100 million euros on green technology for giant work.
Yes. So what you said is absolutely right. We have one of our mentors, Ahad, who actually conducts regular sessions on electric vehicles. We do have programs on
Where
electric vehicles as well.
there, next week, I
So
think 7th, we have some battery technology.
yes, exactly. That's the one I'm talking about.
But
So
why don't you share your contact number? What is the other gentleman name? Normally he talks on automotive thing.
I think it's I'm not sure which person you're referring to, but I'll see to it. The contact information is kind of restricted because
Okay, okay.
due to security reasons, due to some other aspects as well. So
We can send a mail, no, so that
yes.
we can
So
interact.
essentially, like students can actually contact via LinkedIn. They can actually find us on LinkedIn. You can just go ahead or LinkedIn or Heamnt Fegade, and you will easily find me there.
You have a
So
Bangalore office also?
yes, we do. Yes.
A Bangalore office, probably we need him. I don't know how to get. Last time also I asked this information.
So it's
Bangalore.
I think it's an HSR layout
Okay,
in Bangalore. So yeah, you can visit there. You'll be able to easily find this information on our website.
Okay.
I'll just put our website's link in the chat box.
Yeah, you can put it in a chat box. Thank you. Thank you.
Thank you very much. Yeah. This is our website. You can go and check it out. Again, those people who have not received their certificates and have said this particular thing, I just wanted to mention this thing. People who have registered for both the webinar through the website and the form that I had just shared, I'll reshare it again. So both these things you need to do. You need to register on our website. You need to also register to this feedback form, submit this feedback form in order to receive your certificate for this for this particular session, and for the same goes for the last ones as well. And through this, basically, once you submit this feedback form, you will be able to avail a free course from our end. Our experts will understand your requirements, understand which area you want to focus upon, which area you will have interest in, and accordingly guide you through the process of how you can succeed and how you can get skilled. And you will also receive a free course within that particular domain, may it be design, may it be CAE, may it be CFD, may it be electric vehicle, may it be data science. So that way you will understand, that way you will learn about these domains in which piques your interest a little bit further. And those who and 25% of the all audience who will get access to this free course and who will complete the course as fast as possible, the 25 selected few, 25%, will receive the certificate for the free course that we are providing. That will also be over there and included. So that's about the general details. I'll be here for 5 more minutes, and until then, if anybody has any questions, I'll be happy to answer. Thank you, Dr. Ashish. Thank you very much for the compliment. You're welcome, Ashwin. You're welcome, Hashim. Thank you, Arvind.
Feedback for SAEINDIA.
Could you repeat that, Shiv? Oh, Devendra asks, thank you, sir. Please bring on more session like this on 5th generation fighter jets. That would be a cool concept to cover. Yeah, go ahead, Shiv.
Feedback for SAEINDIA.
Should I share? Okay, I'll share it once again.
Hello, sir.
Yeah, who is this?
Hello.
Yeah. Yeah, Vinayak. Yeah.
Hello, sir.
Yeah.
So how to get that course, sir, on your website, sir?
How to get that course on website? So it's not that. So basically, you have to go to the website. Suppose. Go to the webinar. Click on the webinar and register for this particular webinar through this process. Basically, your name, email. This will basically give us the information, and accordingly, we'll be able to set up a one-on-one mentor session with you or experts, and then they will be able to guide you through the process. So once you join this session through here, also once you fill this feedback form over here, one of our experts will get in touch with you. They will set up a meeting with you in order to understand your requirements, your needs, and then you'll be able to get the access to the free course in your desired domain, basically.
Hello, sir.
Yeah.
Sir, I was not received a certificate of today's session, sir.
Today's session. So today's session certificates will be issued after a couple of weeks, because there are at least 2 sessions that we do on a weekly basis. There will be around 45, 50 or 100 people attending the session. Actually, it will take some time to generate these certificates and circulate it with the students. In that case, in case you haven't received any certificates for your previous sessions, you need to check all your folders, all the spam folders and etc. things in order for you to understand, or basically check which email you have applied from, so that you can actually have
Certificates via mail?
Yes, certificates will be received via mail. Sir.
Okay. All certificates, previous session certificate?
Yes. All the previous session certificates were circulated via email. Every single certificate that we generate is being circulated via email.
Okay. Thank you. Thank you, sir.
Yeah. Yes, so Devendra was saying like 5th generation fighter jets. Okay, that's a cool concept. I'll look into it. Like Devendra, what can we do, and what should be explored in that. So I think it's about time, guys. Hello. Yeah,
yes,
Bunny, do you want to say anything? Okay, never mind.
No, sir.
Never mind. So it was great chatting with you. It was a very interactive session. I really liked it. People contributing and sharing what they know, exploring. So this is a way to learn. This is a way to explore and keep learning. Everyone keep exploring. It was a very nice session. It was great chatting with you all. And stay tuned for more. Have a nice evening. Take care.
Thank you, sir.
Yeah. Take care.
Thank you, sir. Thank you, sir.
Thank you, sir.
Yeah. I'll take your leave.
Okay, sir.
Thank you, sir.